All right, so here is our formal concavity test. The first thing that I want you to notice is that it's the concavity test. This is not the second derivative test. So the concavity test is not the second derivative test. We are going to have a separate second derivative test that we'll see at the end of this section. The concavity test is going to tell us where it's concave up and concave down. The key thing about this is that you have f double prime, f double prime, f double prime, f double prime. Nowhere in this concavity test do you see the first derivative. So when you are working with the concavity test, it is only f double prime. So the first step in testing for concavity is to make sure that we really emphasize to ourselves it's about y double prime and y double prime only. We're going to go through a very similar process with increasing and decreasing, but now with the second derivative. So we're going to set the second derivative equal to 0 or does not exist. Again, you always want to have a little mention of the domain. You'll notice here the domain is all real numbers because there's no denominator, there's no square root. So you can carry on without getting too concerned about what the domain function is. All right, so we're going to take our first derivative. That's going to give us negative 10w. The plus 8w is a linear term, so it goes to the coefficient. And then the plus 1 is a standalone constant, so it goes to 0. So that's my first derivative. Now, the first derivative does not matter with concavity, right? What do we care about with concavity? We care about the second derivative. So we keep going and we say, okay, my second derivative is negative 10. And then the plus 8, of course, is going to go to 0. Now, you'll notice that I'm then supposed to set that second derivative equal to 0 or does not exist. Now, if I set this equal to 0, there is no x to solve for. So basically, I'm going to ignore this completely, this negative 10 completely, because there's no x there to solve for. Now, that doesn't mean that you just kind of throw your hands up in the air and say, I'm not going to do anything. What that means is two things. You can draw your derivative number line, and if you draw your derivative number line, there's not going to be a number to put down on your y double prime number line, which is totally fine. What you would do is you would say y double prime is negative 10. And you would simply notice that there's no number to plug in because there was no y double prime equals 0 number. And you would notice that this is a negative number. So that means on the derivative number line, our derivative is always negative 10. So the derivative is always negative. All right, so that's a little bit of a different thing than what we saw with increasing and decreasing. So here there's no x to plug in. And we can just say y double prime equals negative 10 always. And so y double prime is negative always. Now, what does that negative y double prime mean? That negative y double prime means that it's concave down. And specifically, it's concave down on the entire interval, negative to positive infinity. So this question is a little different. We have no x to solve for. We just have a negative 10 derivative. Technically, we didn't need to draw the number line. We could have up here just noticed that negative 10 is always negative, so therefore it's concave down. But it's good to just kind of draw the number line, have that discussion. So concave up is nowhere is it concave up, and it's concave down from negative to positive infinity.